Hello and welcome everyone to the fourth session of the Schoolyard Forest Design Lecture Series. I'm Lauren McKenna with Green Schoolyards America, and Dante Sudolevsky will be assisting with tech today, and we have a number of our other staff present here today. Today's agenda will include some introduction and updates from Green Schoolyards America, followed by a wonderful presentation by our guest speakers, and some audience Q&A time. This series is part of the National Schoolyard Forest System, which is a large-scale initiative to increase tree canopy on public school grounds across the United States to directly shade and protect pre-K through 12th grade students from extreme heat and rising temperatures due to climate change. California is the first state in this initiative, founded by Green Schoolyards America and 10 Strands in partnership with CAL FIRE and the California Department of Education. We hope that the sharing of information and expertise about designing and caring for schoolyard forests in lectures like this one will help inspire you to spread the word and help shift what we see as schoolyard to be an advocate for systems change. We hope that you'll check out our National Schoolyard Forest System library, which includes many resources on designing, implementing, caring for, and using schoolyard forests, as well as curriculum ideas, helpful articles on the rationale, and case studies. I'd like to just highlight two resources in our library: the California Tree Palette for Schoolyard Forests, which we will share in much more detail today, is intended for school districts, landscape architects, and school communities to easily select trees that are appropriate for a schoolyard forest setting and will thrive as temperatures rise due to climate change. Also, the general guidelines in how to select trees for your schoolyard are geared toward assisting schools in choosing suitable trees for their region and schoolyard environment that will thrive long-term. Both resources can be found in the Design, Implementation, and Maintenance chapter in our library and the link in the chat. And again, we'll go over both of these things in much more detail today. Regarding this lecture series, today is not the last one. We invite you to join us again in 2024 for more of the Schoolyard Design lectures. We will take a break over the winter holidays and reconvene on Thursday, February 1st, 2024. Same time, 11 a.m. to 12 p.m. Pacific Standard Time. We'll continue to have lectures at the same time, the first Thursday of each month throughout 2024. If you are already registered, you need not register again. However, you might have had an issue this morning. Please do invite your friends and colleagues next time. Some topics we hope to cover in the next installment of lectures include stormwater management, air quality, thermal and heat comfort on schoolyards, wildlife habitat, and much more. Again, all topics are presented through the lens of including schoolyard forests as part of a living schoolyard. In the meantime, we hope you'll check out the recorded lectures from fall 2023, which include many great lectures, especially an overview of what schoolyard forests are, some key design elements, and how to center children in those designs. We also have a growing collection of schoolyard forest case studies. We hope to include more over time, especially from outside of California. And if your community has a schoolyard forest or any related initiatives, we'd love to hear about them. There is also a survey link on that case study page where you can share information and photos. We hope to highlight some of these in the coming year. So today I'm very excited to welcome our guest speakers, Arran, Joe, and Jenn, who will outline the process for selecting trees suitable for a schoolyard with considerations for function, benefits, safety, and maintenance. They'll frame the importance of using a climate-adapted tree planting palette focused on trees that will provide the greatest benefits for schoolyard and local ecosystems, as well as how to use some useful online tree selection tools. We will have Q&A time with the speakers after all three have presented. So while they're presenting, feel free to type your questions in the chat and we'll address as many as we are able to at that time. either live or in the chat. If you like, you can note if a question is directed to a specific speaker or specific slide they shared. We'll also post the speakers' bios in the chat, and at the end of each presentation, any relevant links to their research or presentation. So a little bit about each of our guests. Arran Schultz is a landscape designer focused on bringing rich connection and immersive interaction with nature into the everyday spaces where children play and learn. She works with Bay Tree Design to create landscapes with healthy ecological systems, community reflection, and beneficial experiences for children. Joe McBride, PhD, is a professor emeritus of landscape architecture and forestry at the University of California, Berkeley. He taught courses in ecology, environmental analysis, and urban forestry at Berkeley before retiring in 2014. His research focused on studies on forest ecology, urban forestry, vegetation management, fuel management, and the impacts of climate change on urban forests in California. He is the author of 2 books, The World's Urban Forests and Reconstruction of Urban Forests After World War II. He has done consulting work in urban forestry, vegetation management, fuel reduction management in California and beyond. He is a fellow of the Society of American Foresters, a member of the Chinese Academy of Forestry, and a California licensed professional forester. And he has received awards for teaching from the University of California, Society of American Foresters, and Council of Educators in Landscape Architecture. And lastly, Dr. Jenn Yost is professor of botany at Cal Poly San Luis Obispo, where she teaches ecology, evolution, and flora of California. She studies trees from around the world, urban forests, and climate resiliency. She works with the Urban Forest Institute to create tools that help people better understand their urban forest and make good decisions about tree selection. So without further ado, I will pass it off to Arran to get us started. Thank you for being here.
So our brains are hardwired to find comfort and connection with trees. They've been proven to bring a sense of calm and well-being. Their mere existence has been shown to cause a decline in disruptive behavior in schools, both on the play yard and in the classroom. And trees are more than the shade they provide. We form a kinship with them, and they can become a part of a community. The trees are not as simple as installing a manufactured product, but I will ask what manufactured product becomes better and grows with age. Instead of devaluation, there's an immense value created over time through the growth of a tree. When you think about what makes a park or a college campus a comfortable and beautiful place to be, the mature and large stature trees there almost certainly are what come to mind. So selecting the right tree species for a schoolyard is critical, as the trees are a long-term investment. And designing a schoolyard forest involves careful consideration of tree selection and placement, as well as a plan for periodic care and maintenance. So right trees in the right place with the right plan. I'm going to start with briefly talking about the right place. Some of the considerations that go into where trees are put on a schoolyard. Green Schoolyards America has some wonderful resources on this topic in their Schoolyard Forest Resource System library, which Lauren just mentioned. I would recommend looking at that to get your bearings, and also the previous Schoolyard lecture by Lisa Howard and Alejandra Chiesa, which focused on the design process. Today, we are going to focus on specifically which trees to select, but of course that does depend on where the trees will be and the space provided for them. So I want to touch on design considerations. And specifically, there's several strategies that will increase the likelihood of developing healthy and beneficial trees, increasing play affordances and decreasing maintenance costs. In the graphics to the right, I've shown 2 different ways to plant 6 trees. In the option at the top, 6 tree wells were cut out of an asphalt yard with benches surrounding the trees to block the tripping hazard caused by the planting area. Planting trees in a tree well surrounded by asphalt is basically the same as planting them in a container the size of the planting area. Roots cannot spread easily under playground asphalt, which can sometimes be extremely thick, having built up over successful asphalt pours. Alternatively, the option on the bottom a location is chosen on the schoolyard for a forested area where the space has natural surfaces, living soil fed by a healthy system, and the potential for understory plantings. The tree roots have greater access to water and air and greater space to spread out. They have more rootable soil. In this configuration, larger trees may be selected, which create greater benefits for longer periods of time as they age. Even if you plant a large stature tree in a small planting area, that tree will not develop to its full potential. It will not provide the shade you're looking for, and it may not even survive. The images above are from the same elementary school, which has a wonderful tree canopy with mature trees that were planted with the intent of creating a shaded play space. The school includes play structures within this tree canopy that stay comfortable and provide a calming, protective space for play. The planter style trees do add to this canopy at the edges. However, if they were the only trees on the schoolyard, they do not provide the same level of benefits as those larger species planted in a forested area. A dedicated schoolyard forest has the opportunity to plant larger trees, and a campus is the perfect place to cultivate a tree that will grow and live and thrive for many, many years. As a large tree matures, its benefits continue to grow: more shade, deeper and cooler shade, living soil, more carbon sequestration, more stormwater capture, more habitat creation, and on and on. A smaller stature tree likely costs about the same to install, however, will have a much shorter lifespan. Its benefits will be shorter lived, as well as it can never deliver what a large tree can. So creating schoolyard forests with space for larger trees, you will be providing benefits to students and the community for a long, long time. A space that may become the soul of a campus. Again, there are very few capital investments that grow and improve themselves. However, by selecting large stature, long-lived species suited to your climate, you can put in motion the beginning of a hugely beneficial part of a school campus. If you look at this graphic, a long-lived tree will be outperforming a smaller stature tree in terms of benefits quite quickly. And at the end of the relatively shorter lifespan, the smaller tree will die and need to be replaced starting from scratch, or maybe there won't be the funds to replant it at all. Alternatively, the larger tree will be fully established when the smaller tree dies, and it will be an important part of the campus, and it will still continue to grow and improve from there. Thinking into the future is so important when planting trees. You can't plant a gorgeous 60-year-old oak tree, but you can start that process in motion today by selecting large stature trees, planting them in large areas of rootable soil, and setting up a good maintenance plan. And smaller trees can be effectively used as understory to larger trees within the schoolyard forest, providing a more human scale, and for existing areas where only a small tree would fit. The final note on design considerations relates to maintenance. Grouping trees within a schoolyard forest or nature exploration area means that weekly maintenance chores, such as blowing leaves off pavement, are greatly reduced. Leaves that fall on the floor should be left in place. These boost the ecosystem, suppress weeds, and provide loose parts for students to play with. Alternatively, trees that are situated as islands surrounded by pavement will drop leaves and debris onto the pavement, which could create a slipping or tripping hazard and may need regular maintenance to remove. So now that you've dedicated a space in the play yard for a schoolyard forest, which trees would be best to put there? I want to talk about some of the goals and considerations that go into tree selection, because schoolyards are a unique environment with particular needs and concerns. Firstly, it's important to choose trees that will easily thrive in the school's climate. Next, student benefits should be considered when selecting tree species. Children gravitate to trees and can love them to death, but once established, trees can bring great learning opportunities. They create free loose parts for students to play with. Trees help block pollutants and clean the air. And of course, they can help reduce the health risks due to overheating. Finally, maximizing the ecological benefits not only helps the school forest ecosystem to thrive and helps to connect the larger ecosystem of the neighborhood, but these benefits directly feed back into benefits for students as well. Again, bringing in curriculum-related opportunities and demonstrating the cyclical effects of a thriving ecosystem. So the best place to start when selecting a tree is to understand the climate you are in order to choose a tree that will easily thrive. Luckily on the West Coast, sunset climate zones provide an incredible resource which defines microclimates based on the length of the growing season, the timing and amount of rainfall, winter lows, summer highs, wind, and humidity. And this is more useful than the USDA plant hardiness zones, which are based strictly on winter loads. So once you know your climate zone, you can then pick trees that are best suited to your particular area. And we've created lists or palettes of schoolyard forest trees by sunset zone. So once you look up your school zone, you can reference the appropriate list to see what trees you should select from. Taking this idea one step further, considering climate change is important as trees live a long time. The tree you plant today will hopefully be living in 50 or even 100 years or more. So in order to choose trees that will continue to thrive where they are planted, we have adjusted the recommended sunset zones for the trees on the Schoolyard Forest list to account for anticipated climate change. And this research has been generously provided by Joe McBride, who will be speaking to it later in the lecture. Here's an example of a portion of the Zone 17 Schoolyard Forest tree list. The trees are segmented by large, medium, and small size, as well as a section of fruit trees. Each of the trees listed for a given zone are suitable for the zone today, as well as in the predicted future climate for that area. The list shows the climate adapted sunset zone, whether the tree is evergreen or deciduous, the proper sun exposure, its expected height and canopy width at maturity, growth rate, and water use. This information can be useful when selecting trees for a schoolyard forest. However, we've also included a more extended list that includes information that relates to the various benefits you hope to derive from the trees selected for a schoolyard forest. So the expanded tree list includes the same basic information, as well as more detailed information on adaptability to specific conditions and more specialized characteristics. And the more specialized characteristics are here. There is a section for student benefits and one for ecological benefits and further considerations. There's a lot of data here, but once you've thought about the goals you want to achieve with your schoolyard forest, you can use this expanded list. Excuse me. You can use this expanded list to find the trees that are right for your climate and deliver on those goals. And if you'd like a more interactive filtering experience, like online shopping, much of that data can be found and filtered on the Select Tree website. This is an incredible resource maintained by Cal Poly, and Jenn Yost will be speaking to that tool later in the lecture to explain how that works. Looking at those more detailed considerations, we provided information on drought tolerance, which is a measure of the tree's survivability in the event of a drought period. And this is different than water use field, which shows typical water requirements. Since irrigation is sometimes not possible in a schoolyard forest, this can be an important consideration, depending on your site. Wind tolerance comes into play on certain sites, as well as fire considerations. So schools in a high fire severity zone would avoid more fire-prone species, which ignite more easily. However, this is not as much of an issue in a more urban setting. And finally, phytobuffering, which is the technique of using a living buffer made of dense trees and shrubs to filter pollution caused by a nearby pollution source, such as a highway. So that's also listed on the expanded list. And to briefly explain phytobuffering, situating schoolyard trees between the pollution source and the school can help reduce the amount of pollutants that the school is exposed to. These shelter belts impede the flow of polluted air by creating a dense multi-layer barrier all the way from the ground to the canopy. But correct tree selection here is important. Thinking about how trees can benefit students beyond providing shade, we listed additional features of these trees that can add to the richness of a schoolyard play space. Trees provide a living and dynamic connection to both our local histories and ecologies, as well as cultures and ecosystems in other parts of the world, and bringing those places right into the everyday experiences of students in a very real way. These potential curriculum connections and hands-on learning opportunities can deepen learning and engage students. They also produce loose play parts in the form of cones, seeds, seed pods, flowers, stems, leaves. We've listed which trees produce these interesting tactile objects, as well as those with additional features, such as weeping branches, visible root structures, and aromatic foliage. Each of these features adds more interaction and interest to the schoolyard forest. And by selecting a variety of trees for the space, you're juxtaposing those different features, highlighting the biological differences in tree species, and immersing students in these distinctions. And they'll begin to notice and interact with and discover the science now embedded in their schoolyard. Trees can create the architecture of the play yard, defining spaces and offering those small tucked in places that children gravitate to, bringing a human scale to the often barren and exposed play yard. For more discussion on the health benefits, both mental and physical, that trees can provide, I'd like to direct you to the previous Schoolyard Forest design lecture by Marcella Rainey, Senior Manager, Office of Wellbeing, Children's Hospital, Los Angeles, who outlined how Schoolyard Forests can help to address health and academic inequities through the benefits of a dense and healthy tree canopy. And in that same lecture, Claire Latine, Associate Professor and Chair Hal Polypomona, spoke to the beneficial effects of human-scaled spaces on a play yard, and how breaking up wide open expanses of asphalt or grass with trees or other plantings can elicit feelings of safety and reduce disorderly conduct in students. So back to the expanded list, the final section contains ecological benefits and other considerations. Choosing native California species will benefit the ecosystem and support wildlife, including birds, butterflies, and moths. This owl was photographed at an owl habitat set up at a high school and shows how incorporating natural ecosystems into a school can bring interest and excitement to a schoolyard on top of the ecological benefits. When choosing trees, we love to see a diverse selection. Choosing all the same tree can result in several undesirable outcomes. They may all suffer from the same ailment, insect or climate-related issues, or they may all die around the same time at the end of their lives. Instead of doing that, selecting a variety of trees from this list for your schoolyard forest will not only create a more natural and inviting look, but it will help support local ecosystems. The trees on this list have been thoroughly vetted to thrive in a schoolyard forest, so you can be confident selecting a tree you may not have heard of that fits the zone and site location. Choosing trees that are not the ones that always get chosen also signals to plant nurseries to increase the diversity of their offerings, which can benefit the ecology at large. Finally, there are some considerations to keep in mind when selecting trees to avoid potential problems. If the tree will be planted near pavement, then you want to avoid those species with medium or high root damage potential. However, if the tree will be in a nature exploration area away from pavement, then a visible root system can be a feature for play and provide topographical changes that are beneficial for development of body awareness and balance. We've also considered trees that are high allergy triggers and have excluded some of those. If you're curious about a tree that you notice is missing from our lists, there's a list of exclusions and the reasons on the GSA website if you want to dig into that. So all in, the Schoolyard Forestry list will hopefully provide the tools to select trees that will add to your specific schoolyard forest and benefit students and the community and the ecology at large. Trees really have incredible power to transform our environments. Children deserve to benefit from their presence as well, and hopefully this effort will set in motion the planting of beneficial big trees that will grow and thrive and become beloved. Now I'll pass the presentation to Joe McBride.
All right. I'm Joe McBride. As Lauren introduced me, a retired professor from UC Berkeley. And I was asked to take a look at the lists that the Bay Tree Design had put together from the standpoint of work that I had done on climate change and its impact on trees in California. These lists, as Arran had described, are related to the climate zones in California that Sunset Magazine has put together. Climate zone number 22, which you can see down here, is in the Los Angeles area. And these are trees that are adapted to that area based on the parameters in the Sunset climate zone. In 2018, Igor Lacan and I published a paper looking at the impact of future climate change on tree species in California cities, primarily focusing on street trees. And what I'd like to do this morning is to briefly review what we know about climate change, and then talk about the analysis of climate change that I did along with Igor Lacan with regard to the future suitability of trees in different California cities. And then finally say a little something about the trees that we identified that we feel should not be planted in schoolyards due to climate change. There have been a number of studies about the future of California's climate, and they all point to the fact that temperatures will get warmer. Kayan and his associates in 2009 produced these maps showing the increase in temperature that was anticipated by the year 2099. And as you see, the areas in the southwest part of our state become darker red, meaning that they're going to become warmer, but also at closest inspection, you see that temperatures will be rising throughout the state with some potentially significant increases in the lower part of the Central Valley, as well as the Southwest. In addition to these changes in temperature, studies of climate change have indicated that for a large portion of California, we will see a decrease in annual precipitation. And in Berkeley, California, that will amount to about 5 inches of annual precipitation from 2070, and compared to the 1961-1990 averages. And this prediction is for the period between 2070 and 2100. Another thing that is going to be changing is the amount of snow that we receive in California. The map on the left shows the snowpack in the Sierra and the Cascade Ranges to the north, and that is compared with the prediction made by the California Department of Water Resources to the snowpack in the year 2090. Many of our cities depend upon this snowpack for drinking water. We experienced a serious drought from 2014 to 2016, in which cities like Berkeley basically restricted lawn irrigation of trees because there had been so little snowpack and our reservoirs were getting down to critical levels. We might sum these predicted changes with these two particular slides. It's going to get hotter and we're going to have less water. And those are going to have impacts not only on people directly in the state, but they're going to have impacts on trees in the state, because some trees will not do well under extreme heat conditions. And many of our urban trees require irrigation, and we may not have water for irrigation. During that drought period, trees in Berkeley, California, were significantly impacted by the increased summer temperatures and the lack of water for irrigation. And here are a couple of typical London plane trees along San Pablo Avenue in Berkeley that are exhibiting a significant loss of foliage as a result. And some trees along San Pablo actually perished during this drought. Now, the second thing I want to talk about is the analysis of the impact of climate change on street trees in California. This analysis was based on 16 climate zones that you see on the left that were developed by the California Department of Water Resources and were connected to a program called CalAdapt. For each of these 16 zones, we chose an example city that typified the topography, the geography of each of the zones. And zone number 3, Berkeley was picked as an example city. We used a program called CalAdapt, and there's a link to this program at the end of my presentation that allows one to determine what future temperatures are going to be in the 16 climate zones in California. And this is the data that was derived from that. Our example city of Berkeley, California, currently has a historic July average maximum temperature of about 70 degrees. And by the year 2099, that will raise to 80 degrees. It'll be a 10-degree increase in the maximum July temperatures. And this shows that change. And then what we were doing with this data was trying to identify a comparison city, in this case for the city of Berkeley. Santa Ana currently has the same temperature, the historic July average maximum temperature, as is predicted for the city of Berkeley. Here's another example. Stockton, its summer temperature, its maximum temperature will become close to that of the town of Barstow in California. And so these are the comparison cities that we identified in this process. And Stockton, for example, historically, their summer average maximum was 90. It is predicted to be 101. And the closest city to that now is Barstow, California. So if one would go to Stockton, California and identify the street trees in that city, and then go to Barstow and identify street trees in this theoretical example, there would be missing certain trees in Barstow that were not present in Stockton today. And so if those trees were missing because of the change in temperature, we would assume that they would not survive in Stockton by the year 2099, or if they did survive, they would not perform very well. To reinforce our interpretation of this potential loss of trees, we interviewed arborists and city foresters in each of the comparison cities to find out what species we felt would not be present, were not present at the present time because of temperature or irrigation. For the city of Stockton, there were 4 trees outlined in red here that we predicted based on the increase in temperature that would not be able to survive or do well in Stockton. And these were confirmed in our interviews in Barstow, our interviews with arborists, that they had been tried in Barstow, and because of the high temperature or because of high irrigation requirements, they did not survive, or they stopped planting them because of the irrigation requirements. This is a summary slide of the 16 cities that we used in our particular study, showing in gray the number of species that made up the top 20% of canopy cover in the city, or I should say the top 20 numbers of trees in the city. And the black bars show the number that are predicted to survive in the year 2099. So for Eureka, it's not going to get warm enough to really exclude any of the species that are presently there. But if we move to some of these other cities like Ukiah, about only 60% of the currently used cities used trees are going to be able to survive. And as we get down into parts of Southern California, these percentages, these numbers get quite low if we're inland into this area that was in dark red in the maps predicting the climate change. And so for the study, the 10 climate zones listed here, and I want to remind you, these are not sunset climate zones, but Cal Water Resources climate zones. These trees will not do well or will not survive by 2099 in the particular cities shown. Now, these climate zones are developed and were by the California Energy Commission and were used by CalAdapt for predicting temperatures, whereas the Sunset Magazine climate zones were used by Bay Tree Design to come up with their lists of tree species. And so the issue that was sort of before us was to how do we rectify these two classification systems and identify trees that should not be planted in schoolyards. Here again is the list of proposed trees for climate zone 22 in Los Angeles. And our assignment was to look at this list and see if there's anything there that is unlikely to survive due to increasing temperatures. So that required the comparison of the two climate zone approaches that had been used. And we looked at overlay maps of those particular zones. And for example, zone number 1 here is the sunset climate zone, and it is completely overlapped or is equal to the Energy Commission zone 16. A more complicated situation arises with sunset climate zone 7 because it falls in these 4 climate zones that we were using in our evaluation of the impact of trees on increasing temperatures. So we looked at their proposed list to see if there were any trees we felt should be eliminated based on the temperature change, based on high irrigation requirements that were not listed in Perry's landscape plants for California gardens. And also we utilized the natural distribution of some of the species. And so this is the list of trees that we recommended for removal. It's actually a somewhat long list and best summarized, I think, in this slide, so that we did not recommend that hackberry be used in sunset climate zone number 4. And you can see there are 3 other trees species that were not recommended because of their lack of tolerance to the increasing temperatures in the specific climate zone. It doesn't mean that we're suggesting coast live oak come off the list in other climate zones. It's well adapted to those climate zones. These species here are recommended for removal because of increasing temperature and their irrigation requirements. 3 species were considered for elimination in specific climate zones because of their natural distribution. And we had 1 species that was not recommended for the climate zones they were proposed for by Perry in his book, based on Trees for California Gardens. Here are some links to the various sources that I have been referring to in this presentation, and I will be happy to respond to any questions at the end of the meeting this morning. So I'd like to turn this over now to Jenn.
Great, that looks awesome. Okay, you can go ahead and go to the next slide. So one thing that I want to make everybody aware of is that there is an ever-expanding suite of tools located at this website. So this is the Urban Forest Ecosystem Institute, a website for urban forestry tools that is housed at Cal Poly in San Luis Obispo. And really, regardless of where you are from, I think you'll find many of the resources on this website useful. Go ahead and next slide. I'll just highlight a couple. The California Big Tree Registry, next slide, is on this site. And this is where every individual that is the largest of its species is held on this database. And you can nominate trees from here. And there is a map of where all the champion trees are in California. Next slide. We've also amassed the largest urban forest inventory on this site, which is at this point in time is just for California. So next slide. On this link, you can see all 7 million data points that have been aggregated from many data partners around the state. And so this is our most comprehensive look at California's urban forest so far. And what we see is that over 500 species make up common trees of our urban forest. Next slide. This site has the ability to filter it based on if you care about a certain species or you want to know information about a current climate zone. And so, for example, I could filter for San Diego, which I've done here, and then it will display all the information we have about inventoried trees in San Diego. So here are the most common species in San Diego. The top 2 are palms. And then it gives you a bunch of other metrics about the urban forest in that place. Next slide. And another project that we've been working on is what's called the urban tree detector, because generally inventoried trees only represent public trees, not the private trees in the urban forest. And so next slide. So in a large collaboration with computer scientists, we've been using imagery to try to detect all of the trees in an urban forest. So what you can see here on the left is the blue points are the inventoried trees. And clearly it's missing a lot of the urban forest. And so the red points are all the trees that are still part of the urban forest and contributing to the urban canopy, but aren't in the public right of way. Next slide. And from that data, we've been able to run this over imagery across all cities in California. We've discovered that there's 43 million urban trees in California, which is about 0.8 trees per person in the state. Okay, next slide. So that's just to highlight some other things that are there, kind of unrelated to what we're talking about today. But what is related to schoolyard trees is the Select Tree database. So next slide. So Select Tree, what this is a database of trees and their characteristic. It includes all urban trees. So even though it started California specific, it has now expanded throughout all of the Pacific Islands. And it also includes all the common urban trees across all of North America. So in this database, then we have the ability to search a bunch of different characters and see the trees that match your search criteria. Next slide. So some of the things that you can search on are the tree height, the flower color, the site conditions, the water use, all kinds of things. But most recently, in our collaboration with the schoolyard planting projects funded by CAL FIRE in California and also Green Schoolyards America, we've been working on development of this site so that it serves schoolyard plantings more. So what we've added is the ability to take the list that Arran and Joe were just talking about and serve that up on Select Tree. So you now have the ability to select schoolyard tree as one of your search criteria. Next slide. And so when you click schoolyard tree, it will give you the whole list that's been developed by this team. But you can also add schoolyard tree or any other criteria that you care about. Next slide. And when you do that, you'll see that beautiful PDF that Arran showed, but you'll just see it in a different format, which is with little icons of their trees. Next slide. And for any of those trees, oh yes, you can search any combination that includes schoolyard trees. Go ahead, next slide. So maybe you want a schoolyard tree that also has red flowers. You can do that. So then when you click on any given species, it takes you to the species information page. And so this is a really well curated site of accurate photos of that species, and then a whole bunch of information about the tree characteristics, considerations when planting it, and where it does well. Next slide. And then the thing that we're working on right now is the development of the text for specifically schoolyard use. So coming soon in the near future, for each of those schoolyard trees, you'll have the ability, we'll have added text here that says like, the bark for this tree is great to peel off, or this one students can eat, or this one you should not eat. That sort of stuff will be found on the general info page for each of these species. Next slide. And then another new feature that we have on the site is that now users can search tree lists, and you can get to it from the main Eufy page, or within Select Tree, you can say search tree lists. So if you click on tree lists, go ahead, next slide. You will get a list of trees. And this is an example of the list that we've been talking about today. So the Schoolyard Forests for California. And what's great about these tree lists is that it's a static URL that you can share with people or post on your websites that bring them to the list of trees. You can download the list yourself. You can follow the list with that little heart button so that it shows up in your user account. And then every list also has a series of tags associated with it, and those tags are all searchable. Next slide. So for example, I could click on the publicly available tree list, and I could search for every tree list that is related to the word school. And so any list that has that would come up here. If you worked for a consulting firm or a district, you could tag it with your district name or your firm name. Go ahead, next slide. And so those are the public facing lists, but how do you make a list? Well, we now have the ability within Select Tree to create a user account. And once you create a user account, then you can create your own list, and you have the ability to make those lists public or private. You can have sort of a dynamic list that's based on a search characteristic that you're interested in, which is a save search. You name it whatever you want, your own description. You can tag it with what kind of list it is. In this case, it's school list, which region it applies to, and then any keywords that you want. Go ahead, next slide. And then you can go about just adding trees from throughout Select Tree to your list. And the other thing you have the ability to do is to then add collaborators to that list. So if you're working within an organization and a bunch of people want the ability to edit that list, they can. Go ahead, next slide. And so then if you go to your user account and your list page, you'll see all the lists that you are following with the hearts, or all the lists that you're the owner of with the trash can, and you can edit and create new lists and filter your lists that way. Next slide. And so I will say that this project is under active development. We've been frantically working on it full time for the last several months to try to get it up and running before a lot of the schoolyard planting projects in California start. In the coming months, you'll see links on the page to tree curriculum. And if anybody knows of any good sites that we should be linking to, please let me know. You'll soon have the ability to search from your zip code, and also to search for climate adapted trees from your zip code. So if you run into any IT issues while you're working on this, please email me, because we do have a team of developers who we like ping and they fix stuff right away. So Arran, that user account problem should be fixed right now. Next slide. So that's just an overview of some of the tools on the site and how we're trying to support schoolyard planting projects. And so if you haven't been here before, please visit the site. And thank you very much, Green Schoolyards, for having me. And if you go to the next slide, I'll just say thank you. And it looks like we'll have a little bit of time for questions.
Great. Thank you so much, Jen, Arran, and Joe, for all that great information today. I know we're running a little short on time. If you're still here with us, please look in the chat. Many of the questions are being answered by our staff and by the speakers. But to address some of them that I know came up in the chat, I know someone was asking about, are there resources for folks outside of California. And I would love to offer that question to our speakers, just to address broadly, what are some resources people in other states can look to for advice?
Well, I guess I will say that Select Tree does include trees from all over the country. So that part is useful. And then it does include USDA hardiness zones. So that search criteria will apply broadly. But I don't know about the climate analysis. And it looks like somebody posted a study in the chat that, Richard Halley from the U.S. Forest Service is working on climate adaptation for the East Coast. So if you didn't see that link in there, it's in the chat.
I know Joe had mentioned also just general advice for colder climates, just in our speaking. And I know some people might be curious about that as we enter cooler months.
I'm sorry, was that a question directed?
Yes, that's a question from me to you, Joe, about folks that live in colder climates, if you have any advice to them.
Well, the distribution limit of most tree species is set by lower winter climates. And so we have the U.S. Department of Agriculture frost hardiness zone map. That's throughout, as Jenn mentioned, the United States. That would be one source of information. Recently, they have updated that map, and basically this update shows the impact of climate change on the warming of winter temperatures. And so I don't think it will have any negative impact on the lists that Bayleaf Design has prepared, because it's getting warmer, not colder, in California in the wintertime. It might expand a few species, but at this point, I think a more detailed analysis might be required to really see how significant this new map is going to be for this selection of trees in California.
Someone also noted in the chat that you can also look to your university or state cooperative extension. They may have additional information on native or climate appropriate options. I see that someone has their hand raised, and if I could ask you to put the question in the chat. I know that's hard, so that folks we can address it later. One question that someone put in the chat that I would like to verbally address has to do with climbing risk in trees. So I know we're short on time, but I would just like to say that many schools have monkey bars and things like this. And I'm responding to information given to me by one of our Green Schoolyards America staff. And so philosophically, kids should be able to climb trees rather than monkey bars if located in a forest that has the right attenuation surfaces. But we do understand that that is a concern for a lot of people, and that can be managed with setting, behavioral expectations of what kids should and shouldn't be doing in a particular schoolyard forest area, as well as training trains by early pruning to not have branches that are low enough to climb. And then lastly, I see that there are a lot of questions for, is this just for California? And there are a lot of resources in your own state that are similar. But this is great that we see a lot of interest from outside of California. So we'll do our best to address some of the questions that are unanswered. I know we're at time. I want to thank our speakers, Joe, Arran, and Jenn. We have a lot of information on our website. They have their information that they shared. And we also want to invite everyone here to join us again in February of 2024, where we'll continue this series. And in the meantime, we do have an info email for Green Schoolyard. So if you do have questions, please feel free to reach out to us. Thank you again, Joe, Arran, and Jenn.